Hi, I want to cover how to build the Atari ST Toolkit Docker by Logronoida, the creator of Sidecart cartridge, and I worked with him to add some support for other architectures such as Raspberry Pi, which we're going to do today. I do notice there are some issues on here where we need to change some things, so I'll show you the instructions, and also on issues. Uh, this is how I got started with it. I loaded a request to get it using Windows. So I explained how you can use WSL, which is Windows subsystem of Linux and the Ubuntu, to get this all working under there. So if you want to use, and then I've changed the script because there's a different way of doing it. So you can use your standard PC for doing it. It doesn't have to be a Linux box. And then actually, I covered the Intel Mac and Pi, and that's what we're going to do now. But there needs to be some changes to these instructions, so I'll work them out and push them to a request. Yeah. So what normally happens is you run this curl. It doesn't work because it did work, but Diego moved it to release 1.v1.00, so it can no longer find it. So that needs to be changed. How I prefer to do it is this way. Again, this git clone doesn't work for me. I need to git clone directly from the CLI like this. Maybe I need credentials set up. I don't know. So I go here. I'm in a suitable directory, and I say git clone, and then Control Shift V on a Pi, and it will clone in. Okay. Now we'll come down here. A few mouse issues today, and we want to do this bit. No, I want to do this bit. Come on. So we want to pick up just this bit, and what you would do is Control C on that one, but you can't Control C on Unix. You Control Shift V there, and so we're going to CD to that Atari Docker and make clean release. Hopefully that'll work. And I'll speed this up. Now, what it tried to do at first is to pull it down directly from Logronoida's place. He doesn't have this arch. He hasn't built it on the Pi. So what I would do is offer him the build if he wants it. Um, and I'll speed this up. But what it's doing, and maybe I should look at it and we can see the speed of it on the B top. So it's quite busy on the computer. Let's move this to one side. Whilst it's doing that, let's explain what it's doing. So cd tilde slash software Atari more Docker file. So what I did was I extended it to be able to find the PPA Launchpad net for x64, well, actually for AArch64. So this will now run natively on a Pi 4 64-bit, Pi 5. It will run natively on your Mac, but the Mac can also quite kinkily run x64 without too much problem. Although I'm not a great fan of Mac, but I think that's quite a nice feature. And you could run it under WSL, like I said in one of those issues. So then he pulls down his VASM, which is the assembler, um, and then he pulls down the V-link, which is a linker. C-mini, he says he needs this for a specific purpose, so I grabbed that. And what was the bit here? Yeah, his AGT tools. So he has these advanced game, I don't know what it stands for, advanced game tutorial, I'm not certain, advanced game something. And what had happened was he'd already built most of this stuff for the various Linuxes anyway. So he built it for AArch64 and for x64 and for Debian Max. So this is why I kind of left that as standard. And then it creates this entry point, and the slash temp directory is what we use to mount external or on your Pi. We mount that directory on the slash temp of the Docker, and then it does all the magic. And what I did slightly differently was to make it so that these directories are owned by you. So if we look in the install, there's an install Docker, and this little thing here will pass down the user and the group at runtime, and this is this slash dollar which is used to escape it, so that it comes through the mix when you build it. And you need to then install this in your with sudo in your user local bin. You don't have to, you could put it somewhere different, but it's a suggested place, and then you can use it. So we'll leave this running in the background. and then we'll cover some of the demos. So this will be sped up, and yeah, I will be back in a little while. In fact, what I'll do is I'll pause it now and save me editing it. So, okay, we're almost at the end of the process. It's taken, what, 6-7 minutes so far on a Pi 4, and some of that's my link. Bit of a weird setup I've got here. It's going from my house through to the garage and back again. Crazy. But anyway, so it's almost finished, he said, exporting layers, and we should end up with the local Docker any moment now. There we are. So then it said target release. We have to run that target release. So let's go to target release, and that's sudo /install docker. And that won't be able to pull that off. It should run, and now it's in user local bin. So if we say which stcmd, it's user local bin. If we do an ls-l of which st command, sorry, if we do more of pling dollar, then we can see that it's using his name. We build it for the arch, pardon me, and we got the user in the group. And what this will do is we need this st working folder set, and we pass in the user group so that the files in the Docker are owned by you, who's running it at the moment. Okay, and in fact, if you distribute this to other users on the system, it will pass through that way. Okay, if you installed it globally. So that should be that. Let's have a quick look here. So we followed that bit here. Yeah, sudo dash, there we are, that we could have done that. So now let's not export this at all. Yeah, let's just run st command, and what it will do is whatever the passed next as arguments get pushed into the Docker interactively, that runs in the Docker container and then passes the data back into your file system or on the screen, and that's the magic of it. There it tells you, oh, the st working folder is empty. Okay, so that shows it's doing something. Okay, so what it says is if we go to our myst demo, so let's go to where are we now? So let's go up one, and this is in the Docker. So if we go to demo, okay, we've got some stuff here. So let's see if we can find something with the ASM. That's that one there. Hang on. Demo folder. Here we are. There's demo folder. Okay, so this is wherever you put it. So actually, this looks a bit different to what I. Yeah, actually, this is more like it. I was going to say it looks different to what I'd pushed, but here we go. So let me put this into something like that. So let's cd to ASM. This is more like what I wrote. I think he merged things differently. So here we go. So now we would do export st working folder. And on Unix, you can use this. There is other ways, but this little black back tick on my keyboard, it's the top left, will export that variable. Okay. And now we can do st command. Oh, have a quick look. And you see all we got now is a source and a make file. So we can do st command make, and off it should go and do. And he did it. Okay. And there's an obj directory. So now that wasn't there. Let's look in the obj directory. And there's a hello.o. So if we say file hello.o, it tells us that this is for M68K. And that was pretty damn quick that it ran that, yeah. I don't know if we can well, no, we'll go back like that for a minute. So there, yeah, there's the build asm, make. Oh, okay, that was it. I didn't look in the object. I didn't look in the build directory. Is there a build directory? There is a build directory. Okay, there's the file. Okay, so now we can say file hello.tos, and we have a M68K, and you can copy this into your Sidecart, so you could mount a directory on your Sidecart, copy onto the gem file system, and then put it onto your ST, or you can run this on Atari if you want to emulate it, or you could put yourself a a modem link in, effectively a null modem cable, and move it across onto your ST. So that's that one. Okay, so let's go to the C directory. So we want a pop directory. See if we did that. We didn't. So let's go up one, and again, here we go. So let's push directory. No, up one more. Push directory. So this has a directory stack if you're not familiar with what this is doing, yeah. And so now we're in there. So now we can recall export. So that will recall from the history export, and the PWD is now this folder. And now we can st command make. And I rewrote the make so that they create all the necessary directories. And so now there's a file object .tos. So if we do file obj hello bb .tos, it's a 68K binary. So that's working nicely. What else we got? Oh, hang on, mouse. So now we pop directory and we push directory demo C assembler, CASM. And back in the day, I mean, I used to develop Atari stuff years ago in a job that I worked in for military, funnily enough. But the thing was that it was on the original architecture, and it was lovely because it's what you had, and in the day it was fast. But this is super fast, yeah. So we can recall the export. There it is. And we can recall st command because it's going to do the make, yeah. And there it goes. And what does this tell us that we have here? It does all that rubbish. And in the end, there's a dist. So file dist test.tos, and there we are. It's built it for 68K. libc mini. Let's have a look at this one, yeah. So we pop D, we push the demo C lib C mini, we recall export, and we recall st. So that's going to run the command. Yeah, the pling. I call it pling for some reason. It's a Unix is like by experts for experts, and you learn from people. And if shift one is pling for some reason, I don't know why. Bang is the other one that you use for it. So again, if we file out main.tos, that's a 68K there. What's this silly demo? Oh, Atari Game Tools. That's what it stands for. Okay. Now this is already here, I think. Cd dot dot. Pop D even, right? Pop D, pop directory stack. There's AGT. Okay. Oh no, I don't have AGT tools. I'd have to get that separately. I won't do that today, but you get the idea that we've got Docker images. We have built, in this case, AR64. So this will run on a Pi. This will run on a Mac natively, the M1 chips, M2, M3, or you can do it again on your Intel chip, or you can do it under WSL. And on WSL, let's just cover that quickly whilst I'm here. So with the issues, I could even probably show it if I logged into my box here, which I won't do, but I could do. Well, I might do. Hang on. Issues. Yeah. So what did I say you had to do? So you got this Windows subsystem for Linux, and you have to tell it. You have to put the Docker desktop on your machine, whichever using it non-commercially is available for free. So install Docker desktop. You configure the settings to allow it to interact with WSL. You install an Ubuntu WSL, and then you basically set up like we just done a minute ago. So there's under the settings of the Docker desktop. Does it open up? Yeah. There is a settings here, and you can say use WSL based engine. So that's the first thing you do. Let's go back here. And then you install a WSL, and then in this one you have to do WSL integration for Ubuntu because that's the distro that you've so you tick that and cross that, and now from now on, as long as your Docker desktop is running natively on your PC when you boot after you boot up, then this will be able to see all the Docker commands. and forget about modifying script because it should just work. Yeah. So that's the idea, and you can see now that we're able to the pull down the Sidecart ST, and we could build. And what I did was I then used this to build some tests on the actual um, firmware and the ROM to do some tests of stuff, and I'll be doing hopefully some more dev. Okay, thank you for watching. Hopefully you found that interesting and useful. Take care and have fun.